All right. Welcome, everybody, to the April 2024 Leptos monthly meetup. My name is Luke. I'm super stoked to be here this month, hosting our fourth meetup. We've got some awesome, amazing guests lined up this week. Namely, we have Greg Johnston, the creator, core maintainer of Leptos. He's going to do a 0.6 and 0.7 side-by-side comparison. Also going to discuss some benchmarking topics, which is going to be super exciting. We've got Biscardi on. You can find him on YouTube. He's going to discuss an open source website, which he's built called This Week in Bevy, and it was built using Leptos, Axum, and Islands architecture. So that should be exciting. We've got Oya. My apologies, Oya, if I'm mispronouncing your name. I'm sure I will find out here in about 30 or 45 minutes how to correctly pronounce it live on stream in front of the whole world. So you can tell me then, but we are stoked to have you on. Oya's going to deliver a talk on a library that he's built for finding Tailwind errors, I believe, at compile time. And Mukesh is also going to give an update of the Leptos Use crate, which I know is one of the favorite crates among the community. So without further ado, I'll bring you on, Greg, and we can get started with the 0.6 and 0.7 side-by-side comparisons. And I got to say, man, I'm super stoked about this benchmarking topic. I'm a little bit of a benchmarking nerd. I love looking at the benchmarks, and I saw that back and forth that you had on X, and I was like, oh man, this is going to be good.
That's awesome, and this will be great because you can tell me everything I'm doing wrong in benchmarking, but I think as long as we're benchmarking our own stuff against our own stuff, which is mostly what I'll talk about today, I think it's useful, and I'll say a word about the whole X thread thing because I think that was interesting too, and that was what one of the possibilities you and I had talked about originally, but. Hi, welcome to everybody who's here watching either live or if you're catching it later. So nice to have you all here. And Luke, thanks so much for organizing these and for hosting again. I just want to spend some time. As people know, if you've been following along with development, I've been working on this 0.7 for a pretty long time. And it's nearing the time of having something that's releasable. My plan is kind of to release a preview, almost like a pre-alpha, maybe sometime over this weekend or early in the week, depending on just how my time works out. And then use that, partial docs, test not passing, features that aren't quite implemented yet, but enough, you'll see an example app in a minute, enough to get a sense of what's going on. And then to try to go for like an alpha release near the end of May, maybe, that has kind of the full feature set, and we'll be testing stuff out. And the reason it needs so much time is just that this is kind of a full rewrite. And one of my goals has been to make it not seem like a full rewrite to all of you. So I think without further ado, I'm gonna share my screen over here and just let people see what I'm talking about. And yeah, definitely put questions in the chat. I'm happy to answer anything live, whether it's about this specifically or about just everything Leptos, anything else in the world. So is my screen up there for you to share?
Hold on one second. Sorry.
Beautiful.
There we go. Yeah.
Awesome.
Gotcha.
Cool. I hope this is big enough and bright enough for people. But if you look at the text here, right, this looks like a pretty normal Leptos app you should be used to. I hope to not scare you with the astounding breaking changes here. So you've got your normal, component macro. You've got your app component. It's returning into view like usual. We're providing the meta context for Leptos meta. And then, we've got the usual, we've got a style sheet here, title. I just added this color scheme for dark mode for people watching the video. And then we've got the router down into the main, right? All of this is exactly how it would work in 0.6. You'll notice, there's just this one little component that's flat routes. There are some small optimizations that we can do when you're not doing nested routing, but you just need to name it in the component. So there's just a small change. It's maybe like 20 kilobytes release mode, binary size, but it also allows for some other optimizations. So I used flat routes for this. And this example is pretty much based on the SSR modes Axum example that's in the repository. And that's what the benchmarks I did were based on too. So, you've got this homepage that's just at the path nothing. And the first thing that you'll notice that's a difference, right, is this path equals static segment. This is something that honestly, I plan to put like a path macro. It's just a way of, instead of you passing in a string here, you can pass in, a single segment or a tuple of segments. And what this allows us to do is optimize the route mapping process a lot, and particularly cut out a lot of the kind of URL parsing, string parsing logic, in a way that I think is pretty significant in terms of the impact. I mean, we'll see that when we look at the numbers. But my honest goal is for you to be able to do something like, this, where you've got post/ID, and to just have that be a proc macro that expands to this. So for it to look a lot more similar than it does in this example. But so other than that, this stuff works the same. You've got the different SSR modes. So you've got out of order streaming. This is an async one. We have an in order streaming example here, right? And that's the component. So that should all look, I hope, pretty familiar to people. Just in terms of boilerplate and layout, one bigger difference is if you go into the main.rs here, a lot of this is similar, getting the configuration and stuff, generating the routes. But if you notice in the Leptos routes, what this does is actually includes the whole HTML boilerplate that right now is kind of hard-coded. So this is really nice. It means that you can do things like, add a class onto the HTML element without reaching down into the Leptos meta components. And it also just allows you to put any arbitrary stuff in the head here, which you don't currently have access to. And it makes it feel a little bit more like you have control over the application. And if you are using Leptos in a way that is not the kind of default happy path template version, this gives you a lot more control. So the people who are using like Leptos SSR with HTMX, for example, this kind of thing, you can actually just generate a whole HTML document and serve it. And you notice like there's a component to insert the hydration scripts. There's a component to insert the auto reload stuff. I don't know why this isn't Rust Analyzer has been hassling me recently. But so if we go back into the application part, this is where you start to see some of the new features. So one small change here, right? I am opting over time for a few more of the like typical Rust naming patterns. So instead of create resource, you can see this this resource new, and we'll provide the same functions and maybe mark them as deprecated or something, but just trying to move toward that more typical Rust struct based pattern. But if you notice here, this has new SIRD. So in the current version, all of your resources are serialized from the server down to the client using the same exact encoding. So you can like opt into SIRD Lite or opt into mini SIRD, or I think even opt into archive currently. But that's on like a per application level, like it's a feature flag on Leptos itself. And there's no real reason that needs to happen. So this just allows you to specify that. And then those are all enabled by feature flags to keep the compile times low, but you can choose on a per resource basis how it's actually being serialized. So that's just a small quality of life thing. If you look at the type of this also, I don't have a good example in this one, but the type is pretty simplified. So it no longer has the input type. And this becomes a bigger thing with server functions and stuff. If you're passing things through context, like the types for resources and for actions have gotten easier to name, basically. But the big difference with regard to resources and to suspense is that suspense now works with Rust's native async system instead of working with Leptos reactivity primarily. So in other words, rather than this old pattern, oops, where's my old example? In the old example, right, you would have like create resource, and then you would have to do something like this. And then that kind of like maps over the inner value, or you could do like .get.map, because the first time these resources were read to start tracking them, they would always be none. So in the new version, resource implements the into future trait, which means you can await a resource. And we have this struct that's just suspend. This is just like a new type wrapper around any future. And if that future can be rendered, then the suspended future can be rendered inside a suspense. So the pattern of suspense now looks something more like this. You've still got suspense, you've still got your fallback. I have a bug here, but you can just insert a suspended future right into the view, or you can do something like this post view. And so if you go up here, right, you see it's like in a move closure. So it's going to react to changes in the resource, just like you're used to. But then it has this async block, and we can get our posts, our actual posts resource there. Like this is the resource. We await the resource. And then the map here is because it's a result, not because it's an option. And the posts are just an actual vec. And so this is really good. This solves a lot of bugs. I've been playing around with what the right API is for this for a while, and people have seen it in a couple previous streams probably. But this is really convenient. It answers a lot of questions that people have, like, how do I wait for a resource inside a resource? How do I combine two asynchronous things and wait for them inside a resource? And it also fixes some edge cases around the order of different suspense, nested suspense components and stuff. And then you can also create these like async derived signals, which look just like a signal or a memo, right? They like take some function to generate their new value. But again, those can be asynchronous and you can await stuff inside them. So here I made like post count, and post count is just gonna wait for the posts resource and then, unwrap the result if it's empty, and then give you the length of it. And so again, just like an example of being able to build reactive things on top of the asynchronous things, on top of the reactive things. And this will be reactive, right? So as the value of posts changes, this will run again, refresh again. And then inside the suspense here, basically, posts view is a suspended future with a crazy type signature. And then this one in here is again like a suspended future. I could have written this as post count dot await, but that's kind of redundant. But to string, whatever. So you can use await just inline in the view here because you're suspending this async block, and that will just wait for that resource to load. And on the server, it can run these concurrently. It can even the resources themselves are parallelized. They're just like spawned as Tokyo tasks. And so, your data loading is just happening on its own. And then once those things are loaded, following the normal rules of async stuff that you would expect, it'll stitch together that view. So that's kind of it as far as the API changes. There are other small things, but if you look at this example, like I hope for anyone watching, this feels familiar and not scary, because it really shouldn't be. Have we got any questions in during that part? And then I want to talk about, why I've spent the last 6 months doing this.
Yeah, we've got one question.
Cool.
Ari asks, he's curious to know how async runs in the browser with Rust. On the server, uses Tokyo, for example. What kind of web APIs are used to process futures?
Totally. So we have always used WASM bindgen futures, which is a Rust async executor that runs in the browser that has been around for as long as there's been a Rust WASM kind of community, probably 4 or 5 years or something at this point. It's existed as long as I've been using this stuff. And WASM bindgen futures, they actually semi-recently, it's probably a few months ago now, had a pretty good update so that instead of being backed by JavaScript promises, it's backed by a queue microtask. So it's kind of a more efficient implementation, but it's just a single-threaded async executor that runs in the browser. And they handle their own scheduling, and pretty much when you when you spawn an async task, it adds it to this queue. And then when one of those gets woken up, it kind of triggers something to check for all of them. So it still works just like Rust async, not like JavaScript promises, which are kind of eager. When you create them, they start polling, right? But I basically created a little crate that I called any spawner, I think, that has a very minimal abstraction. So you can use WASM bindgen futures in the browser. You can use Tokyo on the server to power the reactive system. The GTK example, if anyone's seen that from one of maybe last month, that uses the glib event cycle to power the reactive system. So anything that you can basically spawn a future into, you can use. And it's really nice because those work the same, like as long as those are actual correct sound implementations of a Rust async executor, it works the same across different platforms.
Very cool. I think that's all the questions for now.
Awesome. Yeah. So, I mean, I hope that this is slightly underwhelming. Like, I think the suspense stuff is exciting. I think the suspense stuff will fix bugs for people. I think there are other little nice niche things which are great. And like, it's nice to be able to use async in a way that works and feels cozy in the framework, right? But I've spent like 6-7 months at this point working on this. And the question is kind of why? And so if this feels like, oh man, okay, that's not such a huge difference for something you've been working on for a long time, good, that's the goal. Like a lot of the work has been making it feel like it's not a huge set of breaking changes. But actually the whole internals of everything have been rewritten. And I'm planning on doing a couple of videos later this spring, like in the maybe beta and release phase, just kind of outlining, okay, here's how everything works. But there are some really, really good results that have come out of that. So if I pull up Chrome here, right, I've got on port 3006, I've got the 0.6 version of this demo. On port 3007, I've got the 0.7 version. And you can see, they work the same. There was an artificial 1 second delay that I took out just for the benchmarking purpose. But, this stuff works with the kind of normal streaming and everything you'd expect. These are pretty much identical examples. So if we look in the network tab to see how much WebAssembly we're loading, in the 0.6 example, this is 501 kilobytes. And this is with some optimizations, but this is stable. This isn't like extreme, the nightly build standard stuff, nothing crazy. So 501 kilobytes. And of that, by the way, 100 are SIRD. So I actually created an example of this that's just doing the SIRD stuff, none of the Leptos stuff. So it's like 100 kilobytes of SIRD and then 400 of all of the client-side routing, rendering stuff, all of that. In the 0.7 example, if we go into the network tab, the WebAssembly is 373 kilobytes. So that's 125 kilobytes off of 400 that Leptos was putting into it. The SIRD 100 is staying the same. So that's a pretty good savings. That's like a 30% reduction, I think, in binary size. And this is an interesting example. They range from maybe 30% to 50%, but I haven't found an example yet that I've rebuilt where there hasn't been a significant drop in the WebAssembly binary size. So that's great. If you look, this is something people often don't pay attention to. If you look at the actual size of the HTML response, the 0.6 version is 4.2 kilobytes. The 0.7 version is 2.2 kilobytes. So in other words, that's using just about half the bandwidth in terms of what's going out from your servers, but more importantly, what's coming in through users' devices, and in terms of how much content they have to load. And this is obviously a really small page, so that scales, right? And the reason for that, if you've ever looked at the HTML that we're serving, there's both an abundance of these marker comments, which are just empty comments to keep track of where different components are. And also these hydration keys on elements. And they end up taking up a lot of space. And so this is the 0.6 version, right? And in 0.7, the hydration system works a little differently. We're able to use a lot fewer marker comments. You can see there are still some, which are just basically when there's something dynamic that needs to be swapped out potentially on the page, and we need to know where something ended, but many fewer of them, and none of those hydration IDs. And it's not that they've been removed or something. It's just that the way we're hydrating things is a little different. It walks directly over these DOM nodes rather than looking them up element by element. So it looks for the first child of this and then the next sibling. It'll be interesting how that works out. That strategy can break if people have browser extensions that really mess with the DOM. So I'll be curious to see whether we need to go back to including some hydration keys, but they'll probably be a little less complicated than these ones. And of course, if you've ever seen some of these awful like hydration errors with the panics, with the long strings of IDs and stuff, part of the goal was to make it so that that stuff is all done a lot more at compile time and based on kind of static typings of your view tree itself, and to take that out of this more dynamic zone. So that's pretty cool. Like that's maybe a 30% reduction in binary size and a 50% reduction in HTML. But now to talk a little bit about, what you brought up about benchmarking server-side rendering, the X thread that you mentioned was one of these things that I just kind of got a kick out of, right? Because I don't even remember who it started with, but I think it was somebody benchmarked Next.js, right? So a big React for Cell framework with server components, and created an example that was a pretty simple example, didn't really even load any data. It was a page of like 100 UUIDs that they generated once. And then it was just measuring like, how fast is this rendered to HTML? And the numbers that they were getting for requests per second were like 40. And the numbers for Next.js without server components were, I don't know, 150 or something, right? Like it was a significantly higher number. And so a bunch of these JS frameworks jumped in and started measuring themselves against each other, and it would be like eking out by 10 or 15 requests per second, like how fast can we render this stuff? And so I just sort of made the same demo with Leptos and Axum as opposed to, React and Express or Fastify, whatever they're using. And it was, again, like an order of magnitude faster. It was like 1,500 requests per second or whatever. And it was actually pretty slow, right? Like that Leptos 0.6 server rendering is not actually that fast. There are things it does well, and there are things that it kind of struggles in. So for this one, I thought to be more fair, and of course, like that kind of benchmarking is always silly, right? Like it wasn't actually loading any data. So the only thing it was measuring was the server's own request response speed, and then like the actual rendering of HTML. And smushing together strings is usually not the slowest part of a web application, right? But we can control it, and it's useful to compare. So I took this demo, like these two literal pages, the 3006, 3007, and I thought I would run some benchmarks against them. And you know what? I think that the speed on that tab is going to be too small. Get out of here. Okay, so if I clear this, I just ran a really simple benchmark using work. And this will run for 10 seconds. And I think it's 32 concurrent connections, 8 threads, all hitting this website. And it's going to give us a number of requests per second. And then I'll do the same thing for 3007. There may well be much better ways of doing a benchmark like this. But again, because it's so apples to apples, like we're comparing our own framework running on the same version of Axum across 2 different versions. Okay, so the kind of top line number that hits me here is 0.6, 37,000 requests per second, 0.7, 72,000 requests per second. It is entirely possible that I'm doing this wrong, that there are much better ways of benchmarking. But given that it really is like comparing our framework to our own framework and the same exact page, that's really interesting to me. And I don't know, I haven't looked that much more into it, whether this is some of the changes that we made to make it easier for Axum to move things between threads, whether it's just that length of HTML. Like you'll notice it actually kind of corresponds, it correlates pretty well to the actual size of the HTML pages, where the 0.6 one was twice the size and is serving half as many requests per second. So I don't know. I know that there is a lot of work that I put into kind of optimizing the HTML rendering along with all of the binary size stuff. So it wasn't surprising to me. It was encouraging to me to see a result like that in benchmarking the actual server performance. But so this is a great example to me of just like the only kind of change where you can see improvements across the board without an obvious trade-off, at least a trade-off across those benchmark results, is something where you have actually, changed the paradigm a little bit on yourself. And so that's why I've been spending the last 6 or 7 months, like slowly working through rebuilding the internals of the framework so that people's applications can basically stay the same. You change a few things around resources and suspense that should help people solve some bugs that have been pretty annoying and intractable over the last 2 years. And then hopefully see some significant improvements in rendering, right? And it's not like that's going to take away half the load of your server, right? Because in a real application, the thing that's constraining you is probably not the HTML rendering, it's probably your database or whatever it is. But I don't control the database. I can't make SQLite or Postgres or whatever any faster, but I do control our HTML rendering. So the more of that we can shrink down so that it can just be the server serving stuff as fast as it can, the better. And I did test it against just straight up Axum, returning the HTML and serializing the JSON stuff. And that was like 160 requests per second, right? So even just the stuff that we do to set up the reactive system to make it so that it'll work with hydration and everything, that is kind of expensive. But you could think about it like the 0.6 to 0.7 change is taking away half of the overhead that Leptos adds to Axum, right? That would be like one way of summing that up.
Yeah.
But yeah, that's kind of all I have on 0.6, 0.7. If there are other questions people have, I'm really happy to answer them.
Yeah, for sure. We don't have any questions as of yet, but I'll just say, I mean, I think that is so important to, to recognize like where you can, what you have control over and where you can optimize. And I love the fact that we, in the Leptos community, like we focus so much on that. I think that's so important. You can feel when things are bloated and not running as performant as they otherwise could be. And I don't know if it's just for me a personal preference or what, but I can definitely appreciate that. And that's one of the things I love about Leptos for sure.
Yeah, yeah. And it's, I mean, it's a huge testament to how great the Rust language is and how great the Rust compiler is. Like as much as people, as much as it restricts you in some ways, and as, slow as LLVM can be and stuff, right? Like there are things that I was able to do to implement this that are features of the Rust language, like being able to implement future on something, like having this amazing trait system, having being able to like implement a trait on a tuple, right? Like the things that enabled this are features of the Rust language and how amazing things like the type system is, things like the trait system can be. And then seeing the compiler take that and say, okay, I know that I can eliminate all this stuff in a way that, that the current 0.6 and earlier are just not written in a way that facilitate the compiler doing its job very well. And so being able to see like how much of an effect that stuff actually has, it gave me a whole new appreciation for the compiler and for the language, and just a deeper understanding of a lot of that stuff. And I'll also say, which I've said before, the goal of a lot of this is then to be able to also build on top of it more. Like there was only so much we could layer on top without the current system just kind of collapsing. And I think this is a really good foundation. So I have work I've done on things like, reactive stores where you can access individual fields of a struct reactively without doing the whole memo thing. Work on, other kind of primitives that we can build on top of this, like even little things like better kind of optimistic updates for when you have some resource and you load it, to be able to then mutate that in an action, like being able to use actions like their resources and vice versa. And that stuff all kind of depends on rewriting the internals so that we can do that, getting it into the place where it needs to be. And that stuff I think can probably be like 0.7.1, 2, 3 releases. So yeah, I'm pretty excited. Stay tuned for announcements about, a preview version, and I'm going to have a little demo preview repository for people to check out and just play with. And I wouldn't anticipate that being something that people can just drop in and, oh no, now my app is going to work. There will probably be things that are still missing, but definitely to like clone a playground, start playing around with it. That's the goal for, for me for the next week or so. So
awesome, man.
Yeah, thanks so much. And I'll hand it back to you, and excited to hear from Chris and everybody else.
We actually, while you were just talking, we did have a couple of questions roll in.
Oh, great. Good.
Yeah. So yeah, someone says, this isn't really a question, but I think it's a comment worth reading. They said if 0.6 is around 70 and 0.7 is around 150 and Axum is 160, then 0.7 reduces a hell of a lot more than 50% of the overhead.
Yeah, let me double check the numbers for you. So it's from, do I have, sweet. So I'm going to run the same thing again against just the Axum version. I think that those numbers were off by a little bit, so I'll just put all the numbers back up here, and you can do the math and correct me again if you need to. Yeah, so 160 for the just plain Axum CRD JSON, no reactivity, no hydration, no client-side routing, none of that was 160. 0.7 was 72. And 0.6 was 37. So in other words, 0.6 is like 20% as the speed of Axum, right? Or did I just do that weird thumbs up again? My camera keeps doing this. And 0.7 is maybe half the speed of just raw Axum. And again, like that's raw Axum that you couldn't build on top of that raw Axum to support the stuff that we are doing in the browser. It was just like, what's the baseline? So if we're like getting half as many, it's the difference between half as many and a fifth as many, basically. So it's not, we're not at 80%, we're at 50%, but it's still good.
For sure. Okay. Ari says, I think Dioxys has or had a hot reloading feature when you only edit the HTML and no reactivity. Does Leptos have any plans for something like this?
Yeah, we have that in Cargo Leptos. If you do Cargo Leptos watch -- hot reload, anything where you are pretty much updating static parts of the view, so like adding HTML elements, changing text nodes, that all will hot reload. So it will send it over, WebSocket straight to the browser, and it will patch it. I don't have a good demo of that right now because of the other stuff that's open on my screen that otherwise I would show you. But I know, I think Ben showed it maybe in his talk that's now online. And if not, just ping me in the Discord if you can't figure out, and I can show you. But yeah, I mean, it's the same kind of idea. I think Dioxys has, I've heard them now talking about starting to maybe put some of the funding that they have behind some efforts to improve compiler stuff like that, which is awesome. But we have the same basic feature. And then of course, things like CSS reloading, like as you're updating a CSS file, that just automatically gets reloaded. That's the easy one. But we do have reloading too. So for example, if I took, if I put like a p tag here, and
you're not sharing your screen anymore.
Oh, I'm sorry. I'm not sharing my screen at all, am I? It doesn't. I'll click the buttons to share the screen. So if I've got the same application that I just had, right? And if I go in here and I add, a p tag, and I save this, then yeah, like that in 0.6, as for the last, I think it was February or March of last year that I was working on this. Like if you save this, it will just send that straight to the browser, and it will recompile in the background, and then it will reload when it needs to. So for things like that, and it's pretty good. It's not a perfect system, but we do have it.
Yeah. I was going to say, I don't even think you need to use a tag for that, but yeah. Okay. Let's see. Corvus asks, do you also see faster hydration on the client? I suppose it's really not that important. It's probably already more than fast enough.
Well, so this is actually really hard to measure, and there's not a good measurement even among the kind of mainstream JavaScript frameworks for this. And it's a great question. And so, yes, part of the hydration change that I made, removing those IDs, right? So the way that it currently hydrates is basically everything that has a data H key attribute when it loads. It does like a document dot query selector, right? And gets everything with a data H key, pulls all those into a hash map. And then whenever it creates a new element, if it's hydrating, it looks in that hash map and says, okay, we have that element already or not, which is why when you get those hydration warnings, like, element with ID, whatever, not found, it's because something went awry in that process. The new version, right, starts at a certain point. So like it starts in the body, and because all of the views are, it's like a trait-based thing. So in the hydrate method on the trait, if it's an HTML element, it says, okay, walk to the next child element or walk to the next sibling element. If it's a text node, it walks to the next text node, and it will just directly walk through the DOM. So that should be faster. It's hard to benchmark that. And also, of course, right, probably the main thing determining time to interactivity is not the speed of the hydration itself, but the amount of code that you're shipping before it can start hydrating. So reducing the WASM binary by 30% is basically like a 30% reduction in the hydration time. And then anything on top of it that's faster with the actual walk and the actual hydration process is kind of gravy. But the main thing there is the binary size.
All right. And then last question, Solweo asks, is there thoughts on getting rid of marker comments in the future?
So right, the comparison, just like I will throw this up again. There's a big difference between the two examples in terms of the quantity of them. The 0.6 example has a lot of markers and in places where they aren't needed. the 0.7 example has markers in places where they are needed. And the places where they are needed are things like if you render an option, you need to put something there because we don't have a virtual DOM, right? We're not diffing like the actual DOM against a new virtual DOM and then just removing stuff. It's like once you get to this point in the tree, either there's something there or not. And you need to know if there's nothing there because it was an option that was none, then you need to know like when that changes to some, where do I put the new thing? And so some marker comments need to be there unless we really radically change how things work. Whether the exact quantity of marker comments, I mean, there's something that it makes it more reliable because you know the marker will be there. It's technically possible to, there are different ways that you could do this, right? The way that I've chosen to do it, I think is probably the best and creates the fewest of them and is the least brittle, like is the more robust system. So basically the ones that you'll see in a 0.7 example are anywhere that there are, there's a choice between A, B, or C. It will either be A with a comment, B with a comment, or C with a comment. So that if that needs to change, it will know, okay, I'm going from A to B. So I unmount A and then I mount B before the comment. It's much more complicated to say, okay, well, I'm going from A to B. So I mount B before A and then unmount A, because A could be something that doesn't actually exist in the DOM, like the unit type, right? Like, so you'd still have to put a marker comment for the unit type. Like you can't really get away from them ever unless you're doing virtual DOM or you're blasting out inner HTML or you're doing things that have much worse performance in the client for the sake of pretty HTML. So I think this 0.7, a big goal was removing a lot of them, but I don't think that it's actually possible to remove all of them. And I don't think it's the right idea to do it that way.
Yeah, there was another question, and I think you kind of just answered it, which is how does React and other JavaScript libraries do hydration? Do they also use markers?
I'm sorry to say I don't know that I actually know the answer for React. I think that React, so if you just think about it conceptually, right, whether this is how actual React works or not, when you have a virtual DOM, right, when React hydrates, it generates a new virtual DOM that's the initial state of the page, and it has a page that's the current actual DOM. And so it can walk over that and compare those two things. Oh, is this what I'm expecting? And then hydration can break in the same ways if it's not what it's expecting, right? So there are still hydration issues, and then it can maybe bail out and replace the whole page or whatever they want to do. That doesn't require markers, but it requires things like keys in your code, or, like it needs some way to know if I'm at a p tag and what I find instead is a div, is that because the state is different between these two things? Like, is it some browser extension messing with it? I guess if it finds something that's not what it's expecting, it's the same exact problem. And it has to replace it from there. But you never know, like, is it just that one element disappeared and the rest of the page is fine? Or is the whole thing need to be replaced? So like, I don't know. I don't think that the markers, I've never understood the problem with markers, particularly when it's 2 or 3 or 4 on a page. They're just a comment node. They don't even mess with CSS or anything, right? They don't exist in that sense. And in the actual HTML, it's 3 characters. In the DOM inspector, it'll show up as a comment. But if you just do open bracket, exclamation point, close bracket, that is a comment in HTML. And so it's like 3 bytes in a string. I think that they bother people aesthetically when they're then in the DOM inspector or something, but I don't know, they're super, super useful for this kind of thing.
Right on. All right, well, I don't see any more questions for now, so I think we'll move on to Chris Biscardi, unless there's anything else that you have, Greg. Since
awesome,
I rudely got your name wrong at the opening, I've got like
hey man,
people introing. I thought maybe we should change all of our handles here, like on the labels to Chris.
Right,
So
exactly. Yeah.
yeah.
If I could update, if I knew how to StreamYard well enough to update it live, I would right now. But no, that's awesome.
Yeah.
So thank you so much, and really excited for Chris and everybody else on today. And thank you all for being here. And people, feel free to ask me questions off stream anytime. So take it easy. Thank you
All
so
right.
much.
All right. Thank you so much, Greg. All right. So next up, we've got Chris Biscardi. If any of you don't know, Chris Biscardi has got an awesome YouTube channel. I've been following him for a long time. I'm super stoked to have him on. He's got a bunch of great content. He was kind of an early builder with Leptos, and was really kind of putting a lot of great content out there when Leptos was kind of in its nascent stages of development. So anyways, so I'm super stoked to have him on. He's got great content. Go check him out on YouTube. And Chris, how are you doing, man?
I'm doing okay. How are you doing?
Good, good. So you're gonna talk to us about this week in Bevy, which is an open source site for basically all things Bevy, correct?
Yep. That is true. Leptos app, open source site. You'll be able to find the code on GitHub after the talk if you're interested. Yeah.
Yeah, the code, the link to the GitHub is actually in the YouTube description as well to this video.
Wonderful.
Yeah.
That's amazing.
Yeah.
So
yeah, so tell us about it. So it's a Leptos Axum site with islands architecture, correct?
yes, it is a Leptos island site. It's using Axum. I have a couple of things I can show.
Yeah, absolutely.
See if I can get it to work.
Yeah, no worries. If you just share your screen, then it'll pop up and then I can bring it up onto the actual stream.
Unless StreamYard isn't going to recognize anything. All right, it's fine. We can just talk about it.
Yeah, no worries.
So yeah, it's a Leptos site. It is Axum, tower sessions, islands, all the fun stuff. I've been doing, I don't know, web for over a decade and React since 2014 in production. And more recently, all of the stuff that I'm building tends to be WASM. So very, very cool. This week in Bevy is kind of a Bevy ecosystem roundup. It's mostly a content-based site. There's a whole admin backend content management thing in the backend. So the user-facing side of things is not terribly complicated in that sense. But there's a whole backend where I'm using action forms and I'm using all that good Leptos stuff to, be able to even put in all the data every week. I'm using syntactic ComRack for a lot of markdown rendering, Cloudinary for images. The site is deployed compute-wise on fly.io and CDN-wise on Netlify. That switch, which I think was enabled by 0.6, 6 something or whatever. That was huge for me because I do a lot of my Leptos sites both on Fly and Netlify. Which means all my static assets are coming off from Netlify, and having that built in is really, really nice. The performance is wonderful. Total line count is about 10,000 lines of code. So this is this week in Bevy. You can click read issue and scroll down if you want to on any of them. Again, a lot of content, a lot of images, a lot of markdown, all in a database. The network payload on the site is about 20 kilobytes of compressed WASM, so not a whole lot going on the front end dynamically. I think my font files are bigger than the rest of the site combined, which is really, really nice. It gives me a nice boost of confidence in terms of shipping more WASM stuff. Memory in production, super stable. There was one memory leak, I don't know, a month ago, 3 weeks ago. I don't know what time is anymore. But other than that, it's just rock stable at 66 megabytes or megabytes or whatever. I have some slides that I'll drop into the Discord afterwards that have some graphs and stuff. but yeah, the response times are within a couple hundred milliseconds. It's incredibly stable for me. Works really well. Makes me just want to do more and more and more in Leptos and WASM. I don't think
That is super cool.
It's GitHub login for the auth stuff, which is very cool. Yeah.
That is very cool. So let me ask. So how was Islands? Getting onto Islands architecture. I actually built out my first site with it, I don't know, a week or so ago, and I don't know, reading the documentation and using it, I didn't find it to be particularly difficult. And it was actually quite fun, just conceptually wrapping your head around it, how it works. So how was it for you? What was your experience moving over to Islands?
So I've been using Leptos since before there were releases, right? So it is very, we'll say, I'm very used to diving into source or diving into anything I need to dive into, which makes it really, really easy, you know, for me anyway. I don't necessarily think that everybody would get or have it so easily. But yeah, I mean, for me, it's been great.
That's awesome. And you know, since you've been this may be a good opportunity to ask. So, you know, you were a very, as you mentioned, a very early adopter of Leptos. So, what have been that kind of the main for you, kind of the main how do I ask this? Like not the main areas of improvement, but what are the things that you've noticed, either in developer experience, or it could be, you know, it could be developer experience, it could be performance, it could be anything like that. What would be you know, was there anything that really jumped out at you, or that you remember being like, wow, that's what an awesome update, or anything like this kind of over the course of the last, you know, year or two that you've been using Leptos?
Well, I mean, like before Leptos, I really wasn't doing much WASM stuff, right? Like I said, like I was a very JavaScript person, been deploying React-based frameworks since before there were meta frameworks. So like the idea that WASM was even a possibility these days is, I think, a very strong statement in itself. So the idea that you can do anything that you would do in a normal, modern, like React meta framework, that you can just do that with Rust and with Leptos and with WASM now. And it's acceptable, right? It is not, like I think some people who maybe looked into it in the past are thinking things like, oh, it's like hundreds or thousands of megabytes or something, which it is just not, right? Like I'm shipping, you know, 20, 50 kilobytes of WASM just for this one site. And then, you know, that goes up a little bit the more you have non-Islands use cases, the more WASM you ship, the more interactivity there is. But I'm very, very happy with Islands in general, and with Leptos.
Totally. And just for my own curiosity, have you done much work with like WASM bindgen, WebSys, any of this, particularly like around Bevy or anything like that?
Yeah, not really around Bevy particularly, because Bevy kind of takes care of you know, working on the web for you. But I do take contracts. That's kind of how I do educational, I do YouTube, and I do like Rust consulting effectively. So I've done some things with, you know, WGPU and WASM bindgen, and there are people asking me to do Leptos stuff for them, greenfield things.
That's cool.
So yeah.
That's awesome. Are they specifically asking for Leptos, or?
Yeah, I just had one. I had an email come in yesterday, I think. That was like, hey, we have a greenfield site and we want to do it in Leptos. So
that's awesome. Did they give any reason as to why?
I can't talk about ongoing like stuff that much, but like, yeah. there are people asking for Leptos sites and for help with Leptos sites.
That's very cool, man. Very, very cool. That's exciting. Well, we do have one question here. Ari asks, how did you go about styling? Is it just Tailwind?
Yes, it is Tailwind. So I do have, if you want to enable the share screen, I didn't realize that wasn't on. It is just Tailwind. So I do take a DX hit in terms of like adding things to the DOM, adding classes and things like that. But in return, I get, you know, plenty of sites and things like that. So there's GitHub login in the admin backend. this is where most of the code goes into. Whole list of issues, action forms for all of the data, saving into the database, images, stuff like that. When you run past the last slide, it closes the presentation. Here's the performance stuff that I was talking about earlier. So memory graphs over the last, I think this is 7 days, just absolutely stable. HTTP response times. There are a couple spikes here that I have not looked into that you can see on screen, obviously. But other than that, very stable. This is last few days, 5 days, 4 or 5 days for a little close-in zoom view. But yeah, very, very happy with Leptos and Tailwind, and or not Tailwind specifically, but Leptos and Islands, and yeah.
Awesome. Yeah, that was actually, the Tailwind question reminds me, that's something that I would ask. What do you generally reach for like, do you have component library that you prefer? Have you used Leptonic, or do you use like Daisy UI, or do you just kind of roll your own components? Like, how do you think about components and styling and things like this with Leptos?
Usually build my own stuff. Like I have a lot of experience doing web stuff and components and component architectures and, React and other frameworks. So I usually build my own things, except for things like Leptos Use. So those are super useful in terms of having like those generic hooks that, are just reusable for various things, whatever you need, using different browser APIs. It's much easier in my mind to use like a Leptos Use hook than it is to reach into WebSys and do something myself manually.
Yeah. Right on. All right, I'm checking for questions, and it doesn't look like we have any. And we are already coming up on the full hour, and we still have 2 speakers. So unless there was anything else, oh, actually we do. Okay. Greg asks, what have been the most painful APIs / design patterns, etc., for you when using Leptos?
For me, I feel like I don't necessarily feel a lot of pain, because I went into Leptos knowing that it was, I did it pre-release, right? Like before there was a 0.1. So I go into things with a very different mentality. I don't really feel pain in that sense. But when teaching things, getting people to understand like when something is reactive and when it isn't, and just being like, just throw it in a closure and hope it works or whatnot. That was really painful. But then we got those nice warnings in the console whenever something was like, hey, maybe you meant this to be reactive. It's not now. So things like that were really nice. But yeah, I wouldn't say it's necessarily painful for me.
Awesome. Very cool. Okay. Well, Chris, dude, thank you so much for joining us today. Like I said, for me personally, I can say I was super stoked to when you agreed to come on and to have you on. So hopefully this is not the last time we have you on. Next time you do something and you want to talk about it, you've got an open invitation. And I'm sure I speak for everybody here that we appreciate you coming on and sharing this week in Bevy. Everybody, if you want to contribute or go check it out, be sure to check it out. You can find the link to the GitHub in the YouTube description for this very video. So thank you so much for joining, Chris.
Yeah, thanks for having me.
All right, take care.
You too.
All right, so up next we have Oya. Now I'm going to I'm very curious to know. I've already screwed up one name this show, so let's see if I'm doing another. How do I pronounce your name? And it looks like I think you're muted. I just tried to unmute you, but I can't unmute you. There you go.
Oh, that's true. Can you hear me now?
Yeah, now I got you.
Perfect. Just say oye.
Oh yeah. Okay. Well, I think I was pretty close.
Yeah, or you just say yeah.
Yeah. Okay. Cool. All right. So you're going to talk to us about, is it twust? Is that what it's called?
Right. It is twust.
Yeah. Okay. And it is a library which is intended to catch Tailwind errors at compile time. Is that correct?
Correct.
Yep. All right. So yeah, man. Floor is yours. Tell us about it.
Hi everyone. Maybe I'm gonna do a quick presentation first before.
Sure.
Okay.
If you share your screen, then I'll put it up on the stream.
All right, I'll share my screen now. Second. Okay, let me just share my tab. Can you see
And
my
while
screen?
he's, yep. And while he's getting his screen up, just so everybody, if you have questions for Oye, be sure to put it in the YouTube chat, or if you're on the Discord server, I'm monitoring the LeptosConf Discord channel. If you don't want to put a question in the YouTube chat, we, like always, will do a short Q&A at the end of our guest speaker here. So yeah, so okay. So tell us about it, Oye.
So the old essence of Tailwind or twust is just to catch your error. That's the primary thing, although I do have some other features planned. But this came when I'm a big fan of like static checking, right? So most of my projects are mostly about catching bugs at compile time. And when I started using, like I wanted to work with like Leptos, and Tailwind was like a no-brainer. It's like I wanted to be able to like catch my error like instantaneously. So I started working on like twust because I felt like it should be possible. And the main motivation was that I tried to like explore different libraries, and I would have to run through different hoops just to get things working. Like I would have to run some CLI. So I thought like about creating twust. So the general idea of twust is that you could have a very complex class name put together, but if it's invalid, you're gonna get a static error. So for example, if you look at this is a fairly like complex class name. I don't think you should do this. But you have like a bunch of like strings. And if you, let's say you take, what would be an invalid stuff? Let's say you take this out. I hope my stuff doesn't fail me this time. Okay. But the general idea of my new Vim, let me be sure that my new Vim is not messing up now. Okay, yeah, so those could like be valid. The general idea is that, for example, when you make this kind of mistake, you get the error like instantaneously. So if we try to check this now, you see it actually starts around this point where we've got like the text around this. And the reason is, yeah, this is a valid fraction with the epsilon. And if you change this to k, it's invalid. Or like if you have a wrong unit, for example, yeah, it's invalid, right? So that works for things like that. And if you have the wrong modifier, like active over, it catches that. So basically, it helps you catch issues with your Tailwind class name like immediately, and it works for a very complex scenario also. And in addition to that, it actually supports more like custom stuff. So for example, there's this config where you can add a bunch of stuff. So you can add like new classes here and new modifiers, and these are just like, you can think about them as like a whitelist, and you can even extend the colors name and everything. And with this, it takes all these things into consideration when it's doing your like type checking. And the reason I decided to opt for JSON is because you can still integrate this into your Tailwind settings by just importing like this Tailwind config JSON. So that's the main thing, I think. Okay, yeah, this is it. So generally, it's here, and I have some motivations and everything you can find on the GitHub. And some other stuff I'm planning for this is I'm planning next up to like support ability to like join, to have like more complex class to support like conditionals. And I do have my way that I'm thinking about this in terms of like ergonomics, which I tend to prioritize in most of my work. So That's mostly it for like twust. If you're
That is
interested or if you
awesome.
have any question, let me know.
Yeah, that is really, so we've actually got some positive feedback. We've got AWs as well. That's pretty sick in the chat, and I would have to agree.
Thanks.
Yeah. Yeah,
So
that's very, very cool.
thank you.
All right. Then I don't see any questions in the chat. Okay, actually, yeah, take that back. We've got Ari asking a question. Ari's holding it down on the questions tonight. So thank you so much, Ari. Shout out to you for asking some great questions here. So Ari asks, very cool. Would the macro trim excess white space between classes? Would the macro trim excess white space between classes?
Excess white space, you mean like something like this? You've got like something like this? If that is the case, I need to like check that. I don't believe so. The main thing is like the macro tries not to modify your classes. So it serves
Yes.
as a static checker. So the main philosophy of this is that even if we find an issue in your code and we could make the modification, we would rather you make the modification yourself. So there's no magic going on. So it's just like checking it. So if there's something, and I could probably add that into the configuration. So for example, you could put some extra rules like disallow extra white space. And when there's an extra white space, rather than taking that off for you, it will give you a warning. So you make the change, because actually when you're using this macro, everything is done at compile time. So it strips away any other kind of functionality. So there's no runtime overhead when you're using this macro, because like it just returns the string for you and make sure it's valid and you're not making some mistakes inadvertently. And also like this uses like a combinatorial like parsing. So that should be like a bit more like performant. So it tries to do everything at like compile time and tells you what to do rather than doing it for you. So there's no magic going on or surprises.
Right on.
Yeah.
That is awesome. Okay. So then if there's no more questions, was there anything else that you had for us, Oye?
Nothing much, but I would say like what I'm planning now is, like I said, conditionals, and if you use something like class names and stuff in like TypeScript, looking to support some of those syntax and in a way that feels idiomatic but not cumbersome to use. So you'd be able to have like array of classes and still do some like static checking with those things also. And that is already in the plan. So, but that's mostly for me. Thanks for listening to my talk.
Actually, we do have another question. Actually, Greg asks, can it be used with other Rust frameworks or templating systems?
Absolutely. So this is like framework agnostic now. So there's no reason why it couldn't be used even on the back end or somewhere else, because it basically just returns the string that you've passed. It just makes sure that it conforms to the Tailwind syntax system.
Yeah,
that's a good question. Thanks.
That makes sense. All right, cool. And remind us, so the link is in the YouTube description. So anybody who wants to check this out can check it out there. And we've got another question. Just fast, are you using Leptos in production or just for personal projects?
So I do have some projects now that I'm using like Leptos for, but not yet like published. And so this journey has actually been going on for about 4 years now. When I like started, because I started with like TypeScript, and I spent about 2 years building some kind of like automation around TypeScript with alongside the infrastructure. But I was hitting a lot of roadblock with like a lot of things, like the packaging system, the like TypeScript itself, the fact that your code would break after a couple of weeks, and I got frustrated, and I was looking for like an alternative language. And somehow serendipity brought me to Rust. And so I started exploring like U. Actually, that was the first thing. But there were some things that didn't quite like resonate with me. And the first time I saw Leptos, I was like, that was the first time I had like strong conviction that I would go fully Rust, because I felt at that point that this would enable me do anything without like sacrificing out. Like the trade-off would be more about me learning about how to manage and contain the complexity around managing my system, but I could technically do anything possible. And so right now, like Leptos is my framework of choice for a bunch of reasons. And what I'm doing right now is actually to build a system around that, with Leptos being like more like the core of the center of what I'm doing, and of course the database and my infrastructure. The plan is to have everything built in Rust, from my infrastructure, my UI, and everything. So I'm also doing my in code like CDK. Something you use like CDK TS. I'm doing the same thing in Rust. So basically, I don't have Leptos in production now, but that is the plan, and that is what I'm working towards. And TWST is just one part of the puzzle, and my other projects also.
Awesome. Yeah, that's really cool. I can say for myself personally, I feel the very same way about Leptos. Sometimes I get pulled into working in, other frameworks and things, and I'm always yearning as soon as I can get back to a Rust code base, and specifically Leptos. That's always exciting to be able to do that. So we've actually, we've got quite a few questions now coming in. So Victor asks, do you have any plans to do anything like the Prettier plugin, which orders the Tailwind classes in the order in which they're applied?
Right now, I've been thinking about this a lot, like building the core Tailwind plugin in Rust and just using WASM to in other languages. But so like I said, the primary philosophy of twust for this right now, so this could be an extension of the project, but the primary philosophy is to not have like any surprises. So it's just to be a static checker. So even when I'm supporting things like joining, merging, like Tailwind merge, things like that, I'm looking for ways in which, rather than merging the stuff for you, I mean, there are some times that you can't do that at compile time because you don't know the conditionals to decide what class should be enabled or disabled. But wherever possible, I err on the side of letting you do it. So like what you see is what you get, right? So that should be the philosophy. So if there's something you don't want in your code, and even if it's something custom, you can go into the configuration, set it. So if someone has extra stuff in your like class name, you can fix it. So you know that what you're seeing is what you're gonna have in production also. So that is what I'm what the primary philosophy. But I'm not saying never to this prettier plugins and stuff like that. And there are things that I'm actually constantly thinking about, using Rust as the core tool to build that, and using WebAssembly to compile and to enable that in such a way that it can be built in other ecosystem also. It can be used in other ecosystem.
Awesome. All right. Well, it looks like that's it. Well, it seems like everyone is super excited about twust. So please go check it out. Like I said, it's in the YouTube description. And Oya, unless there's anything else, I think we'll go ahead and move on to Mukesh, if that's all right with you.
Perfect. Yeah, absolutely. Thanks for having me.
All right. Absolutely. Anytime, man. Anytime you have updates or, you want to share anything, you got an open invitation. So anytime.
Thanks. Absolutely.
All right. All right. Take care. All right. And so thanks, Oya, again for sharing twust with us. Anybody who wants to check that out, again, go to the YouTube description. GitHub link is there. Finally, we have Mukesh on. I'm super stoked to have him on always. Mukesh, you've been on the stream before, haven't you? You've been on the meetup before?
Sure, once, 3 months ago.
Yeah, exactly. So Mukesh is the creator of Leptos Use, correct?
Correct.
Yeah, and so pretty, pretty important, sort of figure in the Leptos world. I know a lot of people use Leptos Use. So we're always super stoked to have you on. So I'll hand it over to you to give some updates, and the floor is yours.
Thank you. If there's enough time, I would like to do an introduction to Leptos Struct Table after the update of Leptos Use. If that's
Absolutely.
Okay.
Absolutely.
Perfect. So I'm gonna share my screen.
Yep.
And screen. Second, that's the wrong screen.
And I'd like to ask you, am I pronouncing it correctly? Is it Makesh or Makesh?
It's Makesh.
Makesh, okay.
But you can call me Chris as well. No worries.
Yeah. I'll just call everybody Chris. Everybody is Chris from here moving forward, and then I can't get anybody's name wrong. Yeah. All right.
Okay. Yeah. So Leptos Use. Since I last talked about it 3 months ago, there have been a whole bunch of new functions, and that's in a big part thanks to a lot of contributors. So thank you everybody who contributed. And yeah, I'm not gonna mention all of them. That's gonna take too long and be probably rather boring. But I want to focus on some of the more maybe important ones or ones that I found especially interesting. If you want to look at what has been changed, you can always go here into the change log, and there's everything listed, all the fixes, all the changes, and all the new functions that have been implemented over time. So let's get started with the first function, and that's use broadcast channel. And I'm going to go over them rather quickly. So if you have any more questions or want to know more details, feel free to ask questions, and I hope I'm going to be able to answer them after. So use broadcast channel, I want to mention that because I actually didn't know about this API before I implemented that one. And maybe I'm the last person on the web who heard of broadcast channels, but in the off chance that I'm not, so this is pretty cool. You can easily create a channel, a communication channel across even windows and tabs of your app. And with this function, it makes it easy to use it from Leptos. So what you do, you just call that use broadcast channel, and just in use storage, you specify the type that you want to send and the codec that you want to use to encode and decode it, because the API itself just allows you to send strings. And then you get a post function and a message signal, which holds the latest received data. And I have it open here in 2 windows. And when we enter something here, send this message, then we can see it is received here in the other window. And we can send something back, and we see it here, right? So that's pretty neat and can be useful, right, in certain situations. So that's broadcast channel. Next one is use event source. So that's kind of the little brother of WebSockets. It allows one-way communication from the server to the browser. It's actually a pretty old API at this point, but quite useful. It has kind of a similar API than what we just saw. It also, you can use it like this, and you also specify the type that you want to receive and also the codec that you want to receive it in, because again, this API only allows for receiving text. And in this case, this example has a struct. We have 30 enabled for this struct, and that's why we can use the JSON codec, which uses 30 internally. And then you get a data signal, which holds, again, the latest data that you receive. And yeah, you can get an error signal. You can close the connection, and you get a ready state to see if it's already connected or not yet. Yeah, so that's that. And on to the next one. Use Clipboard. Gives you an easy API to use the clipboard, read from the clipboard, put something on the clipboard. And yeah, you use it like this. You call use clipboard, then you get a copy function, which allows you to copy stuff onto the clipboard, and you get a text signal that holds the latest copied data in the clipboard. And again, here's a quick demo. I already, oh, yeah. Hello again, you click copy, and now it's in the clipboard, and it shows you it here, right? And if I now paste it, I can right click, right, paste, it is indeed in the clipboard. Okay, and on to the next one again, use cookie. So I guess this might be the most exciting one of all the new functions, maybe. Use cookie, as the name suggests, allows you to use cookies. And the cool thing is this works on the server side and on the client side. So on the server, it will actually set the cookie and also read the cookie from the headers. And well, on the client side, kind of the same thing. The way you use it is also with this. At this point, we are used to this API, I guess, right? You call use cookie. You specify the type that you want to put into this cookie, and again, the codec. In this case, it's an easy example. It's just a from to string codec, and we put there a U32, and then you just get back kind of a normal signal pair, right? A read and write signal, and this is the name of the cookie, and yeah, and that's it, right? You can use that on the server, you can use that in the client, and it just works. You need to specify some feature flags depending on if you're using Axum or Actix. And recently, there's also a spin feature, so you can even use it on spin out of the box. And we can try this demo here. So there are these two cookies set in this demo. You can see them down here in the dev tools. We have these two cookies, counter A, counter B, and the same values, right? And so if I click plus, you can see it immediately updates. And internally, this uses this use broadcast channel that I showed you in the beginning. So it even works across Windows or other parts of your app. If you use this cookie in several places of your app, it will always get updated automatically as a signal, right? So that's really cool, right? I can use click plus here, it will get updated here and in the browser, in the actual cookie store. Yeah, so
Wow.
that's that. So sorry, you wanted to say something?
No, I was saying, wow. I mean, I'm looking over at the chat, and I think everyone kind of feels the same way I do right now, staring at this. These are awesome updates. Anyway, sorry, go on.
I'm happy to hear that. Thank you. And then a thing that uses cookies, so this is kind of the bonus function. This is not a new function. This use color mode. This is now this can now use cookies to store which color mode is enabled. Before it used to be only local storage, and now together with local storage, you can use both at the same time. You can also store it as cookies, and there is also an example here to explain how to use it. You call the use color mode with options, and you enable cookies, right? That's it. You can also specify the name if you want to. But yeah, that's kind of it. And then you, in your view macro, in your app somewhere, you need to add the class to HTML. I mean, often that's how Tailwind, for example, uses these kind of color modes. It's added to HTML as a class. And to make it work on server-side rendering, you have to add this to your template. And then this works with server-side rendering. And I wanted to, I think I forgot to do that. I wanted to show you an app running with this, but I guess I forgot to prepare that. So you're gonna have to take my word for it. This actually works. And once the cookie is set, the cool thing is then you can even disable JavaScript and WebAssembly and all that, and it will still run, right? Because it will actually do the color mode on the server once the cookie is there. So it's even more robust, and you avoid this flickering that you would have if you only use the local storage. Then it will get rendered from the server maybe in light mode or whatever the default is. And if you had set it to dark mode, it would read it after from on hydration, it would read it from the local storage, then set it to dark mode maybe, and you had this flickering, right? And with this cookie, you don't have that. It's on the server side, it's already rendered correctly, and everything is fine.
Yeah.
I guess that's the functions. I wanted to do a final plug for contributors. We have a bunch of open issues. A lot of them are marked as good first issues. They're going to be on the easier side. So even if you're not as experienced in Leptos or even Rust, these might be good things if you wanted to contribute. And I wanted to invite everybody. That's it from me for Leptos Use. If there are any questions, I'm happy to answer them.
Yeah. So we do have one question, and while you answer this question, I'm going to see if I can. If you put that link that you have for the issue link, put that in the private chat here, and then I'll post that into the stream chat so people can follow that link and go check out issues. And if anybody wants to contribute to Leptos Use, that would be awesome. So I will go ahead and move on. I know we have, here we go. Ari asks, can the cookie expiration be configured?
Absolutely. Let me go back to cookies. That's a great question. There are a bunch of attributes that you can set with the options version. In this case, for example, right, we set the max age to 1 hour, and we set the same site attribute, and you can set all the cookie attributes there in the option. And an interesting thing with this max age is that it will even set a timeout, right? So if you specify this max age, it will internally set a timeout on the signal, and after this 1 hour, the signal will automatically turn to none. Yeah.
Okay, great. Ari also asks, what is the design philosophy behind using a signal rather than a callback for the last stored value in use event source?
The design philosophy is to copy SolidJ as use. I try to kind of mimic that API rather closely. I figured that's something that a lot of people already know and use and has kind of battle tested, right? I only changed it when I thought that it wouldn't make sense in a Rust context, maybe with some types or whatever, right? Then there were some deviations, but other than that, I kind of kept to that. And the idea is you usually have functions in signals, and you see the same thing in use WebSocket, for example. And the idea is if you want to have kind of an event handler, you just do a create effect or something like that, or a watch, and then you have your event handler, right?
Got it. All right, yeah. We don't have a lot of questions, but we've just got a lot of general, just very, very positive feedback. Everyone's super stoked about all these updates. I know they always are. And for me personally, I'm always really excited. You get great demos, documentation's fantastic. Leptos Use in general, I know it's just one of those libraries that people very much appreciate. So I think I speak for everybody by saying thank you for all the hard work you're doing there.
Thank you. I really appreciate that. Thank you.
Yeah. Okay. Then.
Awesome.
All right. So
I'd like to move on to Leptos Struct Table, if that's okay.
Yep. Let's do it.
So Leptos Struct Table, this is actually the reason why Leptos Use exists. I wanted to do this, and I wanted to implement virtualization, and I realized I need to listen for scroll and element sizes. And coming from a Vue background, I knew already Vue Use would provide that, and I searched for that in Leptos, and there wasn't anything there yet. And I figured, wow, that's an awesome opportunity to give a good contribution to an ecosystem. So that's how Leptos Use was born. And that enabled then the development of this, which is still ongoing, but I think it's in a usable state already. So in a nutshell, I think this image shows what this is about. You got a normal Rust struct, and the idea is to have as little as possible extra information to get from this struct to a component that can render this table, right? Because often you will have kind of maybe a vec of, in this case, books that come from some API from somewhere, and you want to render them in some sort of table. And this crate does exactly that. There are a bunch of advanced features implemented. There is async data loading, and I'm going to get into a little bit of detail in a moment how that is done. So it's loaded asynchronously in the back from whatever backend or API you want to. And then you have like table stuff, right? You can do selection. Depending on how you configure it, it can be single selection or multi-selection. You can customize all the rendering parts, how a row is rendered, how a cell is rendered. You can customize all of that. There is no default styling, so this is headless, but there are some presets being provided so that you can quickly get started. I think at the moment we have presets for Tailwind and for Bootstrap, and it's easy to add your own also. You can even have sorting, right? If you enable it, there's sorting implemented, even multi-column sorting with prioritization. And then, yeah, virtualization, right? So only the rows that are displayed are shown a little bit more to make smooth scrolling possible. And that plays together with the background loading. So also only rows are loaded that are shown. So you can have huge data sets and just display them. And if you implement it correctly, then only the stuff that is needed at the moment will be shown, and dynamically, as you scroll or click the scroll bar, more will be shown. And I'm going to show that in a second. You can also do pagination, right, which would kind of be the alternative to this virtualization. It's also supported out of the box, and I already explained that one, right? There's a caching, so once you load it, it's going to get cached in memory, and it's not going to reload it again if you already have some rows loaded. Yeah, and if you provide custom renderers, you also can make cells editable. Yeah. So how to use it? You have in this example, you have a struct person, right? It has an ID, a name, and an age, and then you just derive table row for that. At the moment, you also need to derive clone, and then we have this to make this simple example work. This impl vec data provider. So this will automatically create a data provider for a vec of person. And with this, you can just throw a few persons into a vec and just display them with the table component, right? So that's the most easy use case you can use. But obviously, that's not the real idea behind this component. So the real idea behind this component is that you provide a data table provider, which is just a trait that you implement. And everything that implements this table data provider can be displayed in this table component. And there's really only one method that you really need to implement, which is get rows, right? So this is an async method, get rows, and as an input, it gets a range. So that's together with pagination or virtualization, it only tells you, look, I need these rows, give them to me, right? And I'm going to display them. If you want virtualization to work correctly, you also need to implement row count. By default, this will return none, so you don't need to implement it. But then it will be more like an infinite scroll thing, right? Because it doesn't know how many rows there are in total. But if you provide that, it can display the table as if all of the whatever million rows were there, and only show like 100 or whatever. If you want to support sorting, you have to implement set sorting. And then there's also this track function. So if you depend on some filters or maybe a search or whatever, and you want the table data to update whenever these signals change, right, then you need to track them in this track method. And that's really it, right? So I want to show an example where this is already implemented. You can see there are a bunch of different examples showing various aspects of this component, and feel free to dig through them. And I want to show here only one example, which is the server function SQLX. So this implements such a table data provider with some server functions that internally use SQLX to read some data from a database. And yeah, and we have, this is our data table provider. I'm only going to show this part. The other parts you can look at on your own, but this is the most important thing. We have the struct. We store our current sorting, and we have a name, which is a read-write signal, and this is actually the search, a search signal, right? So this is how this app looks. This is the search I was talking about. You can search by name, and if I scroll here, you can see it runs very smoothly. This is quite a big data set. I can click somewhere and it will immediately load. My connection is quite good, so you don't see actually there's a skeleton loading also implemented. And yeah, it will show this data, right? And yeah, it's quite fast. I forget how big this data set is, but I think it's like 100,000 or 10,000. It's big, right? Too big to display it all in one DOM.
Yeah.
And yeah, you can search by name. I have this header, for example, right? And it will immediately search that. And it will reload the data from the server, right? This is not a front-end filtering because we didn't load all of the data. We couldn't even filter it in the front end, but this happens in the back end. And yeah, I believe sorting is implemented as well. No, it's not. Okay. It's not implemented. Okay. So how does this work? Like I said, get rows is where most of the work happens. You have the range as an input, and what you return is a vec of, in this case, customers. This is the struct that we actually want to show. And you also return the range that you actually loaded, right? This will be, in this case, it will be the same thing, or mostly the same thing as the input range that we asked for. But depending on the API that you're using, you might not be able to load exactly the range that was asked for, right? So in some REST APIs, for example, they're kind of paginated and you only can load them in pages. So if this range is not multiples of this page, then you have to load maybe a little bit more. And this way you can tell the code what you actually loaded, and will take care of managing that. Yeah, and then in this case, this is just a server function that is called, right? This is up here, and this the server function, just builds with SQLX. It builds this SQL query to load it from the database. It will make sure with limit and offset to only query the requested range, and then it will just return all of that, right, with some error handling. And that's basically it, right? Yeah, that's basically it. We make sure that we also return the proper range, so the actual range that was read from the database, and yeah, and that's kind of it already. There's also a server function for the row count, which is this server function. You can see there's a select count here, right, which just reads the row count from the database and then returns that. In this case, the set sorting function is implemented as well, but it doesn't seem to work. So I guess I have to check if there's a bug. I just realized. But in this case, the sorting is simply saved, and it's just saved here in this field, and then later sent to the server function, right? So the sort is sent to the server function, and in the server function, then this is actually, well, maybe that's the bug, I guess. So there should be an order by somewhere. but that's not done. Okay, I found a bug. I have to fix that. So there should have been an order by, right, SQL part there where it does the ordering, and then this would work. Okay. Yeah, and finally track, right? Self-named track. So name, this is the read-write signal that comes from this search input field, right? From this one here above. And so we make sure that once that changes, the data is reloaded. Right? That's what this track is for. And if you have multiple such signals, maybe you have more filters or whatever, then you put all of them there and call .track on the signals, and it will do the rest. Yeah, so that's kind of the gist of it. I wanted to show some final thing. So this is completely done in SVG. So the whole table component is completely customized to work in SVG. That is possible as well. And there is a example here, right? You can dig into that, the custom runner as SVG. I just wanted to show that as an example. Yeah, if you want to see more, you can feel free to ask some questions or some other questions. That's the thing that I prepared.
All right. Yeah, we do have one question from Corvus. Could this library be used just for the virtualization? For example, I have a table that's completely client-side, but can get so large that it slows down the browser.
Yes, for sure. In this case, you can just use the simplest use case that I showed in the beginning. So you would just have your data like this, right, in a VEC or something like that. And you add this to your derived table row, and then this virtualization will work in the front end only. If your data is a bit more complicated than that in some other kind of format, you could just implement yourself the table data provider for your whatever it is, and that way the virtualization will simply work.
All right, excellent. If anybody has any questions, now would be a good time to put them in the YouTube live chat or in Discord. I don't see any questions as of now, but I do see a lot of positive feedback. Unsurprising there. Yeah, I know that's super exciting. Greg mentions here that when he was first working on Rust front end like 4 years ago, someone had asked about virtual tables. So good to finally have that in place.
Yes. Yeah, that's also something I needed for an app that I'm building in Leptos. It's not in production yet. But yeah, that's something that's often needed, right?
All right. Okay, well, all right then. I think that's it. I don't see any more questions. So, Mahesh, was there anything else that you had that you wanted to share with us, or does that do it for this time?
That's all of it. Thank you very much. Thanks for having me.
Absolutely. You're always welcome. Like all of our guests and core maintainers and crate authors, library authors, maintainers, everybody, it's open invite. Hit me up anytime you want to come on and talk about what you're working on. But, you know, I've said it before. I'll say it again. You know, I know everybody really loves Leptos Use and the work that you do, Mahesh. So, you know, just from the whole Leptos community, thank you so much for all the work that you're doing. Yeah, so just thanks.
Thank you.
Absolutely. Okay, everybody. Then that does it for the April 2024 Leptos monthly meetup. The next meetup will, as always, be on the last Saturday of the month. I'd have to look at my calendar. I should have done that before I started this stream and get the date up and running. Although I think it's in the YouTube description already. I think I put that in there in the YouTube description. I would be curious to know if anybody prefers to have the meetup on Saturday or Sunday. So if anybody has any feedback, DM me on Discord, or you can, you know, just jump on the Discord server. The Discord invite is in the YouTube description. Jump on the Discord server. Let me know if you prefer Saturday or Sunday. We did have a pretty good turnout this time, people watching live. So I wanted to say thank you for that. So I did just check it out. It is actually Saturday, May 25th, 3 p.m. ET would be the next meetup, unless we get a bunch of people preferring to do Sundays so they can attend live. Maybe Sundays are better, in which case it would be Sunday, May 26th. So anyways, that does it for this time. Thank you, everybody, for joining us. And we'll be on Discord for a little after party. I think we'll probably just jump in the Discord general voice chat. If anybody wants to talk about the stream, talk about Rust, talk about Leptos, whatever you have on your mind on any of those topics. So until next month, I bid you all farewell and thank you for joining.